Welcome to the training on mounted ball bearings presented by the Bearing Specialists Association, materials provided by Dodge and AMI Bearings. We're going to cover the different mounting configurations for mounted ball bearings. On the top left, you'll see a 2-bolt mounted pillow block. The next one down on the left-hand side is the tap base pillow block. Again, that's where the bolts will come up from the bottom to tap into the housing. Next one down is a 2-bolt flange bearing. Top center is the 4-bolt flange bearing. Middle is the pilot flange bearing. This one's a little different. On the back side of that housing, there's a machined circle that actually centers that bearing into the housing for exact alignment. The next bearing down is a 3-bolt bracketed flange bearing. The top right is what's called a take-up bearing, and that's used 2 bearings side on a shaft, and it actually fits into a frame with a threaded rod, and that bearing is used to position a pulley to tighten a belt on a conveyor. The next bearing down on the right is the screw conveyor hanger bearing, and that's used in a screw conveyor where that screw is then allowed to ride and on that bearing and move material dragging against the bottom of that trough. Again, as you look at these mounted ball bearings, there's lots of different configurations. Ball bearings have point contact, and we're going to cover some more detail on that. Other configurations of mounted unit bearings are tapered and roller bearings, spherical and tapered roller bearings. Those give you higher capacity, where a ball bearing gives you a higher speed capacity. Typically, these bearings are used in pairs, one on each end of a shaft. So let's get into the components of a mounted ball bearing. On the left-hand side is the actual bearing insert. It's made from bearing steel. We'll go into more detail about its components in a second. On the right side is you have typically it's a cast iron housing. On the outside is going to be a rough finish. Inside it's machined to allow for the spherical OD of the bearing to align itself and self-align inside that housing. And also pay attention to that mounted unit. There's a grease groove cut into that mounting area that allows for the alignment of the grease loophole on the bearing to allow grease to transfer all around that bearing using that grease Zerk fitting. Components of the actual ball bearing itself, you have, kind of start on the top right with the outer ring. That's where the lube hole is at. You'll see that. And we'll go into more details as you go to mount the bearing into the housing, how it's important to have it aligned with that grease groove. So you have the outer ring. You look inside there, there's a ball raceway where the ball bearing is going to ride. Inside of that comes next is the inner ring, and it also has a raceway where the balls are going to ride. You've got the different steel balls. Depending on the size of the bearing, there might be different numbers of balls in there. Those balls are then held in place by the cage, and that's what keeps the space and allows for the grease to flow all the way around that rolling element. The next item is the slinger, or flinger as some people call it. That's really designed to keep material away from the seal. It protects the seal and keeps contaminants out. The seal is made of different materials, but that really protects the lubricant, keeping it in and keeping contaminants out and protecting the bearing. We talked about the cage. There's different styles. Some are steel, some are brass, some are polymer. Depending on the manufacturer, those are used differently. And then the set screw is typically there's 2 on a ball bearing. And those are used to affix the inner race to the shaft. Let's talk more about the housing. So the housing, again, is typically cast iron, sometimes it's steel. It's kind of a rough finish. The machine part is the base on the bottom side. You'll see that part is machined. And then the spherical seat, loading slot, all that's machined to accept the mounting of that bearing. Most mounted units have a grease fitting that allows for relubrication of the bearing. That's either at an angle like this example, or it's at the very top of the bearing as well. Assembling the mounted unit housing, you take the bearing and you kind of put it on an angle, and there's actually loading slots on the cast iron housing. Slide the bearing in there, and then you actually will twist and pivot that bearing and have it align. You want to make sure that you put the anti-rotation pin on one side of the loading slot, and what that does, that keeps that outer race from spinning inside the housing, protects the bearing. So then you'll pivot the bearing inside until it's aligned properly. And then that now going forward will be a self-aligning pillow block bearing. Mounted ball bearing load capacities. There are two different types of load ratings you'll see in manufacturers' catalogs. One is dynamic load rating, which is the load it can handle when it's in rotation. The other is a static load rating when it's stationary. You'll see those will vary based on applications, and each manufacturer's catalog will detail what those specifications are. So mounted ball bearing loads. Here we're looking at two pillow block bearings, kind of looking at it from a top view with a grease circuit view. Again, this is a typical configuration with two bearings on one shaft. The radial load is load that acts perpendicular to the shaft. That's really a force coming down on the shaft. And ball bearings, because of their point contact, handle that load very well, and they handle it with the ability to have a higher rate of speed than, say, a spherical or tapered roller bearing. A combined load is where that load comes in, the vector sum of the axial and radial loads. That's really coming in as a combination load of that radial and axial. And then the third load is a full thrust or axial load, and that acts parallel to the shaft in the same direction. This one is not great for ball bearings. Ball bearings prefer either a radial or a combined load. There's other types of bearings that handle that thrust or axial load a lot better. So let's talk about the mounted ball bearing series. There's lots of different sizes for ball bearings, and the capacity changes as you go from left to right on this series. Again, this is ball bearings. You'll see the same type of configuration for roller bearings with spherical and tapered rollers. The bigger the size of the rolling element, the more capacity they have. If you look at the left-hand side, you'll see that there's the bearing has a extended ring on one side only. That's a light duty. As you move to the right, the second and third bearing, they look very similar, but they have the same load capacity. But the one in the middle, the third one, has an inner ring on both sides. That just gives more shaft contact and better holding capacity. But from a load standpoint, they have the same capacity. As you move to the right, you'll see the bigger the bearing, the bigger the rolling element, the bigger the ball, the more load capacity that those have. So mounting the ball bearing to the shaft, there's one thing to keep in mind is that the shaft and the inner race are kind of a loose fit. So you can actually take that mounted pillow block and slide it right onto the shaft with ease. You don't have to hammer or beat it on or heat it up to get it on there. It's a loose fit. So what's needed then is you need some type of locking mechanism to lock that inner race to the shaft. And the most common is the set screw. It's bi-directional, allows you to go forward and reverse direction. It's very easy to install. The only downside is it does cause shaft damage when you go to remove it. If you go to replace that bearing, you have to fix your shaft, either file it or sand it or do some type of machining to it to make it smooth again. The next one is the eccentric locking collar, and what's unique about this one, it's really good for one direction only. The way you mount that bearing and the way you set it, you have to know which direction your shaft is going to rotate. It is not good for bidirectional or reversing applications. It uses a collar, and it's very simple to install as well. The next one is a concentric locking collar, and this really is excellent for high speeds. It gives you a 360 clamping force around that shaft for the entire inner race. It's easy to install, and again, it does not make any shaft damage, so when you go to replace that bearing, it's easy to replace it and put the new one on without having to do any type of machining to your shaft. The next one is the tapered bore adapter. This is probably the best one for holding power because, again, it's 360. You have a lot of force along the length of that inner race all the way through. It does require multiple components. It's a three-piece assembly. It does have more involvement in the installation, but again, there's no shaft damage and has the best holding power of any type of mounting method for ball bearings. Let's talk about ball bearing sealing. If you look at the slinger or flinger, as people call it, that's mounted to the inner race. So that actually rotates with the shaft as it turns. What that does, that protects contaminants and material that may get up against the bearing, and it moves it continuously away. On the seal, you'll see that's mounted to the outer race, and it actually makes contact with the inner race on a light contact or medium contact, depending on the type of material. In this case, it's a standard single lip seal, but there are cases where we have double and triple lip and combination type lip seals. But again, the more contact you have with that inner race, the more it impacts the speed capacity of that bearing, more so on the seal being able to maintain that contact. But again, the grease is inside the seal next to the rolling elements in the cage, and then the slinger keeps contaminants out and protects that seal. So let's talk about some different applications. With the various 8 different mounting configurations of a mounted unit ball bearing, it gives designers of machinery lots of options of how they can configure equipment. On the left example is an air handling unit. Again, ball bearings are great for high speed, quiet operation, and balance. Again, it's a very precise bearing. On the right-hand side, conveyors that are dirty, there's lots of contaminants. Ball bearings work great there as well. With, again, that slinger or flinger, it kind of keeps moving that material away from the seal. In this case, you can see that's a wing pulley. Great use of a ball bearing on conveyors as well. Unit handling, this would be like on a conveyor system. This is an example of one that has a clamp collar, that 360 force around the shaft. Again, it's a fast installation, and it really centers the shaft in that housing for the precision equipment to make sure that pulley's riding in the exact right spot. Another example is wastewater treatment. Again, this is an example where it's an outdoor application. The integral adapter mount there that provides that 360 locking through the entire length of the inner race is great locking method. It centers the shaft as well, and it protects the shaft from damage, so that as a mechanic needs to replace that bearing over time, they can undo that locking nut, pull that assembly apart, and then put a brand new bearing on that same shaft with very minimal machining or cleanup. Thank you, and that's the presentation for mounted ball bearings.